Let's look at final exam question number 86 in Electricity Demystified, 2nd edition. If you have the printed book, please see page 340. We're talking about an electromagnetic wave in free space. Remember what free space means. The Earth's atmosphere, or outer space, generally speaking, a vacuum, so that the speed of propagation is the speed of light, or 300 million meters per second. We're talking about this wave with a wavelength of lambda in meters. Here are our relations. The frequency in hertz is proportional to the inverse of the wavelength in meters. The frequency in hertz is proportional to the inverse of the period in seconds. So therefore, the wavelength in meters is directly proportional to the period in seconds. This question is asking us what happens if we increase this lambda by a factor of 49. Well, if we do that, the period t will also increase by a factor of 49. That's choice B. I made the choices in this question just a little tricky because I thought that maybe somebody's gonna get the notion that there's a square or square root relation going on here, in which case they might have picked A, 2401, which is 49 squared, or C, 7, which is the square root of 49. But no, as long as we keep the speed of propagation constant, that is, free space stays free space. We don't worry about what happens if this wave enters say a pane of glass or some other medium where the propagation speed is slower. As long as this medium remains the same, the wavelength and the period vary in direct proportion. So again, our answer is B.